Let's dive into an exciting project where we'll be building a powerful MCP-powered Agentic Retrieval Augmented Generation system, all running locally. To kick things off, this system utilizes a vector database for efficient searching. If the vector database doesn't yield results, it seamlessly falls back to web searches. The components we'll be using include a search endpoint for web queries, a vector database for our data storage, and an MCP client to interface with it. So, how does this work? First, the user inputs a query through the MCP client, which is called Cursor. The client then reaches out to the MCP server to determine the most relevant tool for the job. Once the tool processes the input, it returns output to the client, which generates the final response. Let's break down the steps to implement this system. Step 1 is launching the MCP server. We begin by defining it with a specific host URL and port. Next, we move on to creating the vector database MCP tool. This tool needs to meet two requirements. It must be decorated with the tool decorator, and it should have a clear docstring. Our MCP tool will query a vector database designed to store frequently asked questions related to machine learning. Now, if a user asks a question that isn't related to machine learning, we need a fallback mechanism. For that, we utilize the Firecrawl search endpoint to conduct a web search and retrieve relevant context. The next step is to integrate the MCP server with Cursor. In this setup, Cursor acts as the MCP host client that uses the tools exposed by the MCP server. To connect everything, simply navigate to Settings, then MCP, and add a new global MCP server. In the JSON configuration file, you'll input the necessary details. Once that's done, your local MCP server will be live and connected to Cursor. It will feature two MCP tools, the Firecrawl web search tool and the vector database search tool for querying relevant documents. Now, let's interact with the MCP server. When we pose a machine learning-related query, it will invoke the VectorDB tool. However, for more general inquiries, the system will switch to the Firecrawl web search tool to gather data from the internet. This adaptability is what we refer to as agentic behavior. If you're interested in exploring the code and detailed instructions for running this project, you can find everything you need in the provided repository. To summarize, this MCP-powered Agentic RAG workflow effectively integrates two essential tools, Firecrawl for web searches and the Qdrant vector database for querying. Best of all, everything is set up locally on your machine. If you found this information valuable, feel free to share it with your network. For more insights and tutorials on large language models, AI agents, and machine learning, don't hesitate to